crashing in PERT and CP. So crashing is reducing the project time by expending the additional resources. For additional resources, you require the additional cost, and that additional cost will be bear in addition to that your normal cost. That will be called as crash cost. Your objective in the crashing in the PERT is to minimize the project duration and to reduce the cost also. Both objective has to meet simultaneously. Objective in the crashing is very straightforward. We want to reduce or contract or compress the entire network so that your cost will reduce as well as your duration will also reduce. Right, shortening the duration on an activity will normally increase its direct cost. Duration which implies minimum direct cost is called normal duration, and the minimum possible time to complete an activity is called crash duration, but at a maximum cost. So on x-axis we have activity duration and y-axis we have activity cost. Just now we have seen the normal time and the crash time and the crash cost and normal cost. So that will show on this figure. So this point represents the crash time and the crash cost. Similarly, we can represent the normal time and normal cost. So for normal time, we have actually more time than the crash, and the normal cost is less as compared to crash cost. If we join these 2 points, the given slope is called crash cost slope. This one is the difference between the cost, and this one is the difference between time, as dy by dx. So dy in this case is delta c and dx in this case is delta t. So in the step to approach crashing, we will prefer the first step, crashing activity starting at the least slope value. So the crashing activity starting at a least slope value in the activity to be selected must be critical. Step. So whenever you have to do the crashing, you always select the activity which has the least slope on the critical path, crash that activity by the number of days which is possible according to the network. Then check your normal cost plus the number of days multiplied by overhead cost plus the number of days you crash multiplied by your crashing cost according to your crash cost slope. Then continue this till we have another parallel critical path. When you have 2 parallel critical paths, to crash the activity in both the paths simultaneously. So initially you start the crashing activity by 1 day only, and then you can crash it by 2 days or 3 days depending upon the network available. So we'll take one sample numerical. So in this problem we have 1 to 2, 1 to 3, 2 to 3, 2 to 4, 3 to 4. Normal week duration is given and the crash duration is given. Normal cost is given and the crash cost is given. And we have the indirect cost of 20,000 rupees per week. So let's first calculate the crash cost slope, that is delta C by delta T. This is 14,500 minus 7,000 divided by 6 minus 3. Check this value and calculate for all. So crash cost slope per week obtained is for 1 to 2 is 2,500, 1 to 3 is 1,500, 2 to 3 is 1,000, 2 to 4 is 3,500, 3 to 4 is 3,000. Find out total normal cost. That is the sum of 7,000 plus 4,000, 11, 16, 30. Network diagram like this, 1 to 2 first, 1 to 2, then we have 1 to 3, so we have 1 to 3, then we have 2 to 3, so 2 to 3, then we have 2 to 4, so we have 2 to 4, and we have 3 to 4, we have 3 to 4. The time for 1 to 2, normal duration, 6, 1 to 3, 8. Start with this, we start with at 0. It takes 6 days, so it will finish up by 6 days. It has 2 arrow behind, 6 plus 4 is what? 10. and if you follow this one, we have 8. When we are going for forward, we always select max. It means that the activity 3 will finish up by day 10. Then 3 to 4 from this side is 10. 10 plus 5, 15. And if you come from that side, 6 plus 5, 11. So you have to again select max value from this. So max value equals to 15. It means that your duration of project is 15 weeks. Our normal cost is 30,000. Per day you have to bear, per week you have to bear how much? 3,000. And how many weeks you are working? 15 weeks. So what is the total cost? So we have a total cost equal to normal cost, which is equals to 30,000, plus we have a, so this one is plus 15 multiplied by 3,000. So total answer is 75,000. So your investment for 15 week is 75,000. We want to reduce this cost as well as we have to reduce the duration also. That is the objective in crashing. Now before this, we'll first finalize what is the critical path. For this, we'll start with reverse way. So how you are getting 15? Are you getting 15 via 2 to 4 or 3 to 4? So make it double line. It indicates critical path. And how you are getting 10? You are getting 10 from 2 to 4. So that is a critical path. And then 1 to 2 is critical path. So our critical path is 1, 1 to 2, 2 to 3 and 3 to 4. Now we have the critical cost slope is this one. Out of this 1 to 2. So this one is critical activity. This cost we can consider 2500 because this cost is less than what? 3,000. So it will be always benefited per week by rupees 500 if you crash it by 1 day. Then 2 to 3 is a critical activity. This has a better advantage because if you crash this activity by 1 day, then your saving equals to what? 2,000 rupees. So that is why we will prefer this first than this one. And last is what? 3 to 4. So 3 to 4 is this one. So even you short it, your gain will be equal to what? 0. But you can very well crash it without any saving. So we'll prefer this also. And this will not come in the picture. And this will not be come in the picture because these are non-critical activity. First of all, you have to draw the number line here and then you start with first. So this one is 0, which will start on 0th day. Then we have to go to 2. 2 will finish up on 6th day. So 2 will finish up on 6th day. Then we have to go to 3. 3 will finish up by 10th day. So 3 will finish up by 10th day. And then 3 to 4. 4 will finish up on 15th day. So 4 is finished up by 15th day. To first draw your critical path 1 to 2, how many days? 6 days. Then 2 to 3, 4 days. 3 to 4, 5 days. At the same time, collect your crash time also in the same diagram. Write your crash time in the bracket. 1 to 2. 1 to 2 you can crash by how many days minimum? 3. And 2 to 3 we can crash for 1 day. And 3 to 4 we can crash by 3 days. Meaning is that this activity this activity 1 to 2 can minimum require how much time? 3 days. 2 to 3 can be minimum require 1 days and 3 to 4 will minimum require 3 days. It means that 1 to 2 can be crashed by 3 days, 2 to 3 will be crashed by 3 days, and 5 to 4 will be crashed by 2 days. The minimum time required for this one is 3 days. Minimum time required for this one is 1 day and minimum time required for this one is 3 days. That is why you crash by 3 days, you crash by 3 days and you crash by 2 days. Now we have the second connection from 1 to 3. So we'll start from this point. 1. 3 will be completed. This is another path here. This is this path I am showing. 1 to 3. How many days? 8 days. So somewhere up to 8. Here you draw full line. This is just exactly below 8, and the remaining point you show by dotted line, and check that you are connected to point number 3. Number will not come here. It is just a line. We start from 1, this is a 1, and it goes to 3, but have a different path. And how many days it take? 8 days. So from 0 to 8 you have to draw the full arrow, and it is connected to 3, so remaining you draw by dotted line, and you write here 8. And what is the crashing for this one? This one is 1 2 3. So 1 2 3 crash is 5, but will not going to crash it because 1 2 3 is a critical path or is not a critical path? Is not a critical path, so we'll avoid it. Out of this critical this crash course slope, which one is the minimum value? 1000 is minimum value, so we will crash this. Now how many days we can crash it? So first of all you have to check where is 2 to 3. Is 2 to 3 is here? Is the extra time available from this point to this point? Is it 2 days? We crash it by 2 days. How many time is required from this dotted line, from this point to this point? 2 days. So if I crash this activity, that is 2 to 3 by crash, then I will get this path is another critical path. So what is the decision made? The decision made is that out of this one, which one is a minimum value? On critical path will be selected, and how many days you want to crash. So you have to just check that the another path, that is this path, will become a critical path if I crash it by 2 days. So maximum limit is 2. Possible? So let's do that crash. Right. Crash activity 2 to 3, which has the least crash course slope by 2 days. Because this dotted line has a period of 2 days. So let's modify your network first, then we'll calculate the cost, and then we'll see what is the changes in our total cost. The changes here is that this activity is shift to the left side. So it's shift by left side. How many days? 2 days. So will it, previously it was what, 10? Sorry, it was 10 days. Now will it finish by 8 days? So you have to make one circle here. This is already crash. And therefore, is this also will shift to the left side? So that will show somewhere like this. So we have we have activity number 3 here. This one is activity number 3. This entire thing will be shift on the left hand side. Now you will observe that your project will finish up by 13 days because you have crashed the activity by 2 days. Now this one is this one activity. That is this one 1 2 3 take 8 days. Now this also finished by 8 days. So shall we draw it by full line? Is it dotted? So to calculate the cost at this instant for 13 days, your formula is normal cost plus duration, that is 13 weeks, multiplied by indirect cost minus crash cost minus crash week. How many crash we have crashed it? That is 2 days we have crashed it, multiplied by crash cost slope. So the normal cost was 30,000. So normal cost was 30,000. Right now the duration is 13 weeks. I think indirect cost is rupees 3,000. Indirect cost is rupees 3,000. And what is the crash cost slope for this one? 1,000. And we have indirect cost is 3,000. So your answer will be minus crash it by 2 weeks, and your cost is involved is 1,000. So what is the cost involved right now? And we have reduced the duration to 13 weeks. Now this is also a critical path, this also a critical path. So whenever you have to crash this, you have to take the cost of this as well as cost of this. So avoid this first, avoid this double. First of all, you can check out this one. It is single path. Now 3 to 4, what is 3 to 4 cost? 3 to 4 is 3,000. So we can crash it, but saving is there or there is no saving. But can we finish the project earlier? So that is also benefit. That is also benefit. So can we crash it by 2 days? So let crash, and how many days we have a provision here? Can we crash it by today? Yes, we can very well crash by today. If you crash it by today, it will come equal to what? 3. So we are crashing this 3 to 4 by 2 days. So since it was crashed by 2 days, this 4 will now finish up by 11. So we can show this by 11. So as soon as you write 4, you have to cancel this number also. That is this number. Now this equals to what? 3. So can we crash it further? No, we can't crash it further. So what is the duration now? So duration according to this is 11 weeks. Can we calculate the cost using the same formula? So we have total cost equals to normal cost is 30,000 plus our duration is 11 weeks. Our indirect cost is 3,000. We have crashed it by 2 weeks. And the corresponding crash cost slope is 3,000. For 3 to 4, your cost slope is 3,000. So you have to subtract it 3,000. So this cost is same as the previous cost because you have gained nothing. So this is additional cost you have to again subtract minus 2 minus 1,000. That was the previous cost. One correction here. Make this value equal to plus. So this value will be equals to plus. So if this value equal to plus, then what was the previous value? 71. Now we'll go for this. Now our normal cost is same as 30,000. Our indirect cost is reduced to 11 multiplied by 3,000. And right now we have invested 2 weeks at the rate of what? 3,000 plus previous crash cost you have to bear, that is 2 into 1,000. So what is the new cost now? Can we crash this activity further? No possibility. Can we crash it by 1 day? Yes. But if you want to crash it by 1 day, is this activity also crashed by 1 day? So if you crash 2 to 3 by 1 day, 2 to 3 by 1 day, what is the cost for crash cost for 2 to 3? Crash cost for 2 to 3 is 1,000. At the same time, do you have to crash this 1 to 3 also? So if you crash 2 to 3, your cost involved is 1,000. And if you crash 1 to 3, your cost is extra. That is a simultaneous activity. 1 to 3. 1 to 3 is 1,500. Now this become a critical path now, so you have to take into account of it. Now what is the total cost involved? So total cost involved is 1,000 plus 1,500. Is this cost, total cost is less than your indirect cost. It means that you can save by another 500. So solution is possible. Can we crash this by 1 day, and this will also crash by 1 day? Now just look at this point. Can we crash this activity by 1 day? Yes, we can very well crash it by 1 day. And can we crash it by 1 day? So one solution is that we can crash 1 to 2. But what is the cost for 1 to 2? What is the cost for 1 to 2? 2,500. So 1 to 2 cost is 2,500. And what is the cost for this activity also crash by 1 day? Because both are critical activity. So I have to crash 1 to 3. Then I have to bear another 1,500. This cost goes to 4,000. Is this cost is more than indirect cost? So you will get penalty. And rather than you will be benefited here. So which is a better solution? 2 to 3 will crash by 1 day and 1 to 3 will crash by 1 day. ऐसा आप सोचें. So crash activity 2-3 and 1-3 by 1 day, the combined crash cost is 1,000 plus 1,500, that is 2,500. Let's modify this diagram. This entire graph will shift to the left hand side. That is 3 will now finish up by on 7th. Okay. Now we have crashed this activity by 1 day. So instead of this 8 day, it will start now on, finish up now on 7th. At the same time, 1 to 3 is also crashed by 1 day. So it will also finish up on 7th. So let's place here circle. Now I have very little space left here. But this was 2-1. Now is it 1-1? This is 1-1 now. And this was 8-5. Now does it become 5? and now this is 7, so it will end up at 7. And because of this one, this entire activity will shift by 1 day, and therefore your duration becomes now 10 days. So now duration is 10 days. Now we'll identify is the saving is there or not. So first of all, for calculating the total cost, we have to include the normal cost, that equal to what? 330,000. We have duration of 10 days, and each day your, and in the first crushing your beer how much cost? 2 into first crush, 2 into 1000. So that is the extra cost coming in the first crushing. Then in second crushing you have done extra cost 2 into 3000. So that is the extra cost you have to again bear, 2 into 3000. Plus in this one the total cost is how much? 2500. So this one is 2500 multiplied by, you crash it by 1 week. So this is not days again, this one is week. Repeated or not? Not able to crash this, we are not able to crash this, but we can very well crash this by 1 day, but the cost involved is 4000, whereas indirect cost is 3000. So your cost will increase by 1000, that is 71,500. So this is the most economical solution. So you can finish up your project by 10 weeks and your cost involved is 70,500 rupees.